application is that the FSA and other regulatory environments require the data to be quite secure. So if you're able to crash it and cause data corruption issues, you're actually breaking a lot of the banking standards. So these reserve values that you can use are Nan Infinity, minus Nan, and minus Infinity. A couple of months ago, Adam actually found a vulnerability on a well-known bank's currency application, is that when you logged into the application and you grabbed your bank balance, you could modify the outgoing balance. So in turn, he put in infinity, and it actually came back as the infinity symbol. So these are quite useful words for any tester to do, and a lot of people actually aren't using these. The next section I'm going to talk about is rounding errors. This is actually not illegal in a lot of banking applications, but it's some areas where you can actually start making money from your bank itself. I don't obviously advise you to do that because getting arrested and having a court case is a bit annoying, but it's definitely something that you should do when you're doing a testing. So applications often have to express values with a fixed number of decimal places. So exactly, large currencies such as the dollar or everything else, you'd use this when you're doing your currency conversion. The round to nearest and ties away from 0 is probably the most commonly applied method. And what's good about these two methods is that they're very, very good to abuse. So the most common scenario where these happen is where the currency conversion and the rounding of some sort cannot be avoided. The exchange rate between two currencies, etc., places like that. So if we look at an example here, we want to convert money between a euro and a pound. So the exchange rate is 0.745. So if you do that in a normal currency thing, that would round up to 75. Obviously, 4 is closer to 5 in the convention, it rounds it up. So 1 euro times 0.745 is equal to 75p. If you do this 1,000 times, you get 750 pounds, which is a lot more than you should do, it's £12. If you then take it back to 750 pounds into euros, you gain 1,006 euros. You're actually making €6.71 per transaction. So you're taking money from the bank. But this doesn't always work that way. The bank actually also takes money from you without you knowing this. So this is an area where testers aren't actually looking for with the currency bounded things. It's quite a cool way to make money from your bank, or watch out if your bank's actually taking money from you. Just another thing to consider. And the last section that we're going to talk about, so it's a bit of a whirlwind talk, is logging and attack detection. A lot of the banking requirements require that a lot of information is logged for the banking application itself. And it's these logging mechanisms where you can actually start playing around with. The idea that every tester needs to understand is what is the business requirement of what should be logged. So that's your first thing when you're testing an application. The application needs to distinguish between normal application use and errors caused by malicious intent. And then the next thing is attack logging requirements should also be used as criteria for generating alerts. So when we have a normal banking application, I expect the application to start picking up on when somebody's running a full-blown tool against the front end of the app. I expect them to pick up when I've tried to transfer money to an account that I don't have access to. This is the basic kind of thing. What I don't expect is that when I'm looking at a banking application, I can start doing stuff like log file injection against the application page itself. Now, obviously I know the FSA requirements more than the US requirements, but what the FSA stipulates is that information needs to be stored in a log file in a secure manner. The nice thing about a lot of the applications we've tested, I think only one has not been vulnerable to log file injection, is that we've been able to wipe out any record of our attack when using currency rounding errors or etc. itself, just using standard basic log file injection. And a lot of the times the developers didn't understand this was happening. They didn't have a concept of, right, hang on, you're writing to the log file, what's the problem there? Because a lot of the times they would set the log file to be only 5 megs long and then create a new log file. And after every 10 log files, delete that first log file. So it was very, very easy to script it or to say, right, I'm now going to see if I can start stealing money from the bank. What I'm going to do at the same time, I'm going to start doing log file injection errors. And by the way, I'm going to wipe out all your logging. So they never knew what was hitting them, which is also quite a cool thing. The areas where I expect logging to happen, as I said, tampering with any parameters, deliberate attempts to view unauthorized accounts, your common web application attacks, so your tampering, cross-site scripting, the X and the name they've given it this week, and everything like that. And then what I expect the locking mechanism to do is properly encode itself to prevent attacks through the log themselves. One of the cool things that we were talking about doing the other day, banking applications out there use Oracle Forms to view, and build up the banking things. And the log files there are exported using CSV. So it'd be quite cool if you knew this, to create a log file injection where you could actually start breaking around with the Excel spreadsheet viewer that the application developer is going to start using. So these are the things that the developers need to start understanding, that log file injection attacks are actually quite out there and people need to start protecting. So sorry if this is a bit of a whirlwind talk. The basis of this talk was that I think that a lot of security consultancies out there need to start looking at doing a more methodical approach to testing applications. There was a lot of emphasis over the past couple of years over the more hyped up attacks out there. I'm not going to name names, but there has been a few. And we are seeing more and more applications being passed as secure when in reality they're not. And these are not from companies that I'd expect to miss these basic bugs, but they are. It is happening. I mean, we can see it here. There's a lot more people coming to the OWASP stuff. The OWASP testing guide has grown into quite a well-known document. More and more people are quite clued up on testing methodologies. It wasn't like this 6 years ago. We would have people coming in and looking at application security and just doing a scatter type approach. So it is actually changing. The tools that I recommend everybody use is pretty much a brain. There's no one tool to do everything. I think with any application, you really need to understand the application you're testing. You need to know it inside and out. And that does make us different from attackers. Attackers only really have one method, is get in no matter how they can. As security testers, you don't really have that luxury. You have 5 days on site. You have all the documentation if you need it. And if you want to, you have all the developers there. So people need to start actually interacting with these different teams. That whole days of long black hair and black clothes and just sitting in the corner, those days were pretty much dead. So it's time to move on and grow up. We have actually got quite a few papers on the Corsa website. The two I would recommend the most was Breaking the Bank, Vulnerabilities and Numeric Processing within Financial Applications, and Security Testing Applications through Automated Software Tests. They do go into a lot more technical detail about the concepts I've touched on today, and they're actually well worth reading, especially after you are looking at applications. And that's pretty much it. Thank you. Any questions? New questions? Cool. All right. Thanks very much.